Page 17, number 82. Find the coordinates of the circumcenter of a triangle with the coordinates listed. Circumcenter. You have to know that the circumcenter is formed by perpendicular bisectors. So what you need to do is you need to graph this triangle, take a look at it, and try to go ahead and draw each of the perpendicular bisectors and find where they cross. Now, there is no formula to find circumcenter like we did before with the centroid, so we have to go through the visual method. I'm going to go ahead and zoom in on my graph and plot this triangle. Do the same with yours. So one point is at 0, 0. The next point is at 6, 0. And lastly, 6, 8. I'm going to connect all three. Now we should note that this is a right triangle. So there is something special about circumcenters of a right triangle, which we will see once we go ahead and draw our perpendicular bisectors. So you're going to pick two of the sides. Now it's going to be easiest to pick the side on the bottom and the side on the right because those sides are laying on our axes. So it's going to be much easier to go ahead and draw our perpendicular bisectors. So if I look at the bottom side here, I'm going to look for the midpoint because it's a perpendicular bisector. So my perpendicular bisector should originate from the midpoint of the bottom side. Now the bottom side has a length of 6, so halfway would be at 3. So this is going to be my midpoint. And now I want to draw something perpendicular to that bottom side. Since that bottom side is horizontal, going vertically upwards would be my perpendicular direction. So I'm going to go ahead and draw a line segment going up. Just going to shade in a little bit with this blue. Okay, so that right there is our perpendicular bisector for one of our sides. Let's do the same with the vertical side. The vertical side has a length of 8. So halfway would be at 4. So going up 4 boxes right here is going to be my midpoint. So my perpendicular bisector should originate from that midpoint. Now I'm going to draw my perpendicular direction to the left of this vertical line segment and make it horizontal. So let me go ahead and draw. There we go. Here is our perpendicular bisector. Now notice which point they cross at. They cross right here. And on your paper it's much be easier to see because I have kind of thick font here. So this point is a very special point. If you kind of visualize this and eyeball it, you'll notice that that is the midpoint of the hypotenuse of this right triangle. So our answer is going to be at 3, 4, but you should also note that anytime you have a right triangle and they're asking you for a circumcenter, it's always going to be at the midpoint of the right triangle. So you'll note that these two pieces are going to be equal. So our answer here is going to be 3, 4. Fill that in as the answer for this question. 3, 4, our point of concurrency for perpendicular bisectors. Okay, let's go on to the next question. Okay, so part B of this question, we're continuing along the lines of special centers of a triangle and special line segments to a triangle. Part B, P is a centroid. And then they tell you some measurements. Before we look at those measurements, a centroid is the point of concurrency for medians. And there's some special property about the centroid that you have to understand before you can do this problem. For a centroid, it's going to divide each of your medians in a 2 to 1 ratio. Let's put in this information that they're about to provide to us and we'll take a look at that 2 to 1 ratio. So it tells us that PA has a length of 2.9 and HC has a length of 2.8. Okay, I'm going to zoom in on my diagram and I'm going to put this information in. Okay, so PA is 2.9. And the other piece of information they gave us was the length of all of HC, which is 10.8. I'll use a different color, 10.8. Now, our centroid is here at P. It's going to divide your medians in a 2-to-1 ratio. So what does that mean? That means if I'm looking at JA, which is one of my medians, for example, that means the length from J to P is twice as long as the length from P to A. So if JP is twice as long as PA, which is 2.9, I'm going to do 2 times 2.9 to figure out the length of JP, because it's twice as long as the rest of that median. So in my calculator, 2 times 2.9 gives me 5.8. So 5.8 is the length of JP. All right, it's a 2-to-1 ratio. Let's take a look at HC. Now HC, this length here, again, is going to be a 2-to-1 ratio. So the top portion from H to P is going to be 2 times as long as the bottom portion, PC. In total, since in a 2-to-1 ratio, I have basically 3 even pieces. From H to P, it's going to take up 2 even pieces, and then PC is going to be the 3rd even piece. So what you want to do is you want to take that 2x and that x, and you want to think of it as 3x. So 2x and 1x, right, is going to give you 3x. And those 3 pieces are going to give you the length of the entire line segment, which they told us is 10.8. So think of this as 3x equals 10.8. So 10.8 divided by 3 is 3.6 for the little piece. So if they give you the whole thing for a median with one of these centroid problems, you're going to take the length of the whole median and divide it by 3. What you get is the little piece. So from P to C, this little piece is 3.6. And then the longer piece from H to P is twice as long, so 2 times the length of 3.6. So I'm going to do 3.6 times 2 in the calculator. So that longer piece from H to P is 7.2. And in total, if I add 7.2 and 3.6, I go ahead and I get 10.8. Now let's go ahead and get back to the question and fill in all the information. Okay, so first ask was, what's the length of PC? Okay, so that's that little piece that we just solved for x, that 3.6. So our answer is 3.6. HP is twice as long as that little piece, so HP is the 7.2. Then they're asking about JP. Now JP is the longer piece, the one that's twice as long as 2.9. So I did 2.9 times 2, and I got 5.8. And lastly, JA. Well, JA is the entire yellow line segment. We haven't added the pieces together yet. So let's go ahead and do that now. So to get JA, I'm going to do the 2.9, the little piece, and then the 5.8, which I found after doubling it. And we're going to add them together. So in my calculator, 2.9 plus 5.8 is 16. Oh, I think I did something wrong. Do it one more time. 2.9 plus 5.8 equals, I get 8.7. So my final answer for the length of JA is 8.7. So this is the concept of centroid. The key is that you memorize the fact that the centroid divides each median in a 2-to-1 ratio. So the median, if I drew a quick little sketch here, okay, if I put my median and I put my centroid here, the top portion is twice as long as the bottom portion. It's in a 2-to-1 ratio. That's the key for this question. Okay, let's move on. Number 83. Put an X in the correct column to identify the name of the segment. So our options are either it's a perpendicular bisector or it's an angle bisector. Remember that your perpendicular bisector needs to be perpendicular and it should start at the midpoint. Your angle bisector should visibly cut your angle into 2 equal parts. And then the last option is neither. Okay, so let's take a look. AE. Now I do notice that starting at angle A, it's cutting my angle in half. So I'm going to say that AE is an angle bisector. Next, DG. DG, okay. D is where DG is originating from. And notice that D is a midpoint because it's cutting the left and the right in half. So notice the single tick marks to show you that it's splitting that line segment AB in half. So D is a midpoint, so it's satisfying the bisector part. And then it's also perpendicular because you notice this little right angle. So DG is a perpendicular bisector. Okay, next. BG. Okay, BG. So BG is originating at angle B, and I notice that again, it's splitting my angle in half because I have an arc on either side. So I'm going to say that this is an angle bisector. Next, FR. Okay, FR, where is that? Here it is. So FR, so it's perpendicular. I can tell that right away. But F is not a midpoint. Notice that we don't have markings to the left and to the right of F that show that it's splitting the bottom side in half. So it's not a perpendicular bisector. It's just perpendicular, but it's not a bisector. So I can't say it's a perpendicular bisector. I also can't say it's an angle bisector. It's not splitting an angle in half. It's not even originating at a vertex. So the answer here is neither. And now the last one, DR. So DR, so it's originating at that same midpoint we discussed before. So it definitely is a bisector. However, it is not perpendicular. So that means that this is not a perpendicular bisector. It's also not an angle bisector because it's not starting at an angle. So the answer here is it's neither. It's just a regular bisector, a regular segment bisector. Okay, let's move on to 84. Number 84. List the angles from smallest to greatest of triangle JKL with those coordinates. Okay, let's go ahead and draw triangle JKL. Let's graph it, and then let's talk. So take a moment now, go ahead and graph. I'm going to zoom in on my graph so I can plot my points. Okay, so J is at -3, -2. K is located at 3, 6. And then lastly, L is at 8, -2. Okay, I'm going to go ahead and label these as well. So I have J, K, L. I'm also going to connect. Okay, so here are my side lengths. Now, I am asked to find the measure of the angles, or at least not the measures, but to be able to rank them from smallest to greatest. The issue is I have no way of knowing these measurements. So what I have to do is I have to find the side lengths, and then based on which side length is the longest, that's going to be across from the largest angle. And then the shortest side length is going to be across from the smallest angle. So I'm going to have to use the relationship of side lengths and angles that are across from each other in order to determine which angles are smallest and which angles are the largest. So I have to go ahead and figure out the side lengths here. Now the way I'm going to do it is again Pythagorean theorem. So let's start with JK. If I start with JK, I'm going to create my little right triangle. I'm going to label that I'm going to solve for JK. And I have 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. So 8 squared plus 6 squared equals jk squared. Now you'll notice this is actually a triple. It's the 3, 4, 5 triple as a 2 multiple. So when I work this out, I get 10 for the length of jk. So 10 is my length. Let's go on to KL. So KL, same thing. I'm going to create a little right triangle, and I'm going to count the sides of this right triangle. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5. So 8 and 5. I'm going to go ahead and write KL, and I'm going to do 8 squared plus 5 squared equals KL squared. Now if I work this out in the calculator, 8 squared plus 5 squared gives me 89. So 89 equals KL squared. I'm going to square root it. So square root of 89 is 9.43. 9.43 equals KL. Now the reason why I wanted to square root it is because before we got a nice whole number, not a radical, as our answer. So if I want to do an apples to apples comparison, I want to see these numbers either as whole numbers or as the decimals. But sometimes with the radical, I'm going to think, oh, square root of 89, that must be larger than 10, because I see the 89 and I forget it's not 89. It's a square root of 89. So this is why I actually put the square root in my calculator and wrote down what is it approximately equal to. Now for the bottom side length JL, this one's horizontal, so I can just count the boxes, no need for Pythagorean theorem, and get the length. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the length of JL. Okay, I have all 3 lengths. Now, to figure out your smallest angle, you have to find your shortest side. My shortest side is KL, which means the angle across from it, angle J, is going to be my smallest angle. So I'm going to go ahead and write in that angle J is my smallest angle. So the measure of angle J is the smallest. Now let's figure out the largest. So to find the largest angle, you look for your longest side. My longest side is JL. It has a length of 11. That's larger than 10 and larger than 9.43. So that means the angle across from it, which is angle K, is going to be my longest, or sorry, my largest angle, angle K. So I'm going to go back to my notes where I've been putting in my answers, and I'm going to say that the measure of angle K is the largest because it's across from your longest side. Now what's left? That leaves us with angle L, which is your medium angle. So the measure of angle L is my medium angle. Okay, we're done. Let's keep moving. Last one. Number 85. Use the right triangle to answer the following questions. Part A. Fill out the table and give your answer as a fraction and as a decimal. Okay, so look at all of these options, or rather all these blanks. It's all trig, so you have to know your ratios. So make sure before you get started that you understand that we're following so, ka, toa. Okay, so let's start with the sine of A. Sine is so you should be doing opposite over hypotenuse. Now with angle A, our opposite angle, or rather our opposite side to angle A is the 4. Our hypotenuse is the 5. Okay, so with A as our reference angle, I'm going to put down 4 over 5, which, as a decimal, 4 divided by 5 is 0.8. So 0.8. So the sine of A is either expressed as 4 over 5 or as 0.8. Let's look at the next one. Cosine of A. Cosine is c, adjacent over hypotenuse. The adjacent side is the 3. It's next to angle A, but it's not the hypotenuse. So 3 over your hypotenuse of 5. 3 divided by 5. In your calculator, we're going to do 3 divided by 5, 0.6. So the cosine of A could be expressed as 3 over 5, but if you put that 3 over 5 in the calculator, the cosine of A is 0.6. Lastly, tan. Tan is TOA. So opposite over adjacent. Opposite is 4, adjacent is 3. So I'm going to say it's 4 over 3. In the calculator, 4 divided by 3 is 1.3 repeating. So I'm going to 1.3 repeating, or 1 1/3. All right, let's go on to the second column here. I'm going to erase all of this information, and now I'm going to have my reference angle as angle C. So if angle C is my reference angle, my opposite side is 3. My hypotenuse does not change. It's always the 5. It's across from the right angle. And my adjacent side is 4. So sine of C is opposite over hypotenuse. So it's going to be 3 over 5, which if I put that in the calculator, 3 divided by 5, I already did it before, it's 0.6. So note, cosine of A is equal to sine of C. And we've talked about that before. Cosine and sine are opposite trig ratios. And then we're using A as one angle and then C as the other. And A and C are complementary. They add up to 90. Okay, let's keep going. Cosine of C is c. So adjacent over hypotenuse. 4 over 5, which we've done before. It's right here, 0.8. So again, notice cosine of C is the same as sine of A. So those opposite trig ratios, and then you switch your angle as well. Lastly, tan of C is TOA, opposite over adjacent. So it's going to be 3 over 4, which we haven't done yet. So 3 divided by 4 is 0.75. 0.75. Okay, so those are all of our trig ratios given as fractions and as decimals. Part B says find the measure of angle A and the measure of angle C to the nearest whole degree. Whole degree. So no decimals. Okay, so let's say I'm going to go ahead and solve for the measure of angle C first, since I've already labeled in opposite, adjacent, and hypotenuse. Now, to find the angle measures from the sides, you're using inverse trig ratios. So things that look like sine to the -1, cosine to the -1, or tan to the -1. Since we have all three sides, and we don't have any constrictions because we have all three, you can choose any of these trig ratios to use. Let's say I use cosine. So cosine to the -1 would look like this. I would say cosine of angle C is equal to adjacent over hypotenuse, 4 over 5. Then to put into your calculator, you're going to get C by doing cosine to the -1 of 4 over 5. Specifically, you're going to do cosine to the -1 of what 4 over 5 is equal to, which is 0.8. So let's take a look at it in our calculator. We're going to do 4 divided by 5. It tells us that's 0.8. Now we hit second cos. And it's going to tell us that it's about 36.87 degrees. So C equals 36.87 degrees. But they want your answer to the nearest whole degree. So we're going to round the 6 up. So it's approximately 37 degrees for our measurement. Now, since I know that my angle is 37 for my angle C, the way that I can find angle A is I could just subtract 37 from 90 to see what's left over for angle A. So if I do that in the calculator, 90 minus 37, I'm left with 53. So 53 degrees should be the measure of angle A. But I'm going to go through the process again using my inverse trig ratios because we need the practice to see if I get 53 for angle A. So for angle A, let's go ahead and use one of the other trig functions. So let's go ahead and use, let's use sine. So sine of A should equal, so opposite over hypotenuse. Now recall what we said was the opposite to angle A. Opposite angle A is the 4, the hypotenuse is 5. Okay, so let's go ahead and put that in. Sine of A is equal to 4 over 5. A is equal to the sine to the negative 1, the inverse sine of 4 over 5. Or A is equal to the inverse sine of 0.8. Let's go ahead and do that in our calculator. So I'm going to clear this out. Now I have 4 divided by 5 equals, it gives me the 0.8. I hit second sine, and then it pops out that 53.13 is approximately how much A is equal to. Since we're rounding to the nearest whole number, then yes, it's going to round to 53 degrees. So 53 degrees is the measure of angle A. That's exactly what we said it was before. So it makes sense. Either you find one angle and subtract it from 90 to find its complement, or you go ahead and you do your trig ratio, your inverse trig ratio again. Okay, that completes page 17. We're more than halfway done.